Today we're going to learn about solving and graphing systems of linear equations. And that may seem like a mouthful, but really what we're doing is just taking two different things and piecing them together to find one solution. So let's start off with maybe a real application for this. All right, example 1. You and a friend earned $41 for painting a fence. Your friend painted faster and earned $4 less than twice what you earned. How much did you each earn? So, we don't get paid equally, so we can't just do 41 divided by 2 because your friend's painting much faster. All right, so let's see if we have enough information. First off, how many unknowns do we have? We want to know how much each of you earned. So that's you and your friend. So let's let X represent what you earned, and then Y can represent what your friend earned. So now that we've established what our two variables are, and we tend to use X and Y just because they represent the X and the Y axis, right? All right, so now total means that's our sum, or the answer to an addition problem. So if we add up what we each, you and your friend, that would be X plus Y, that gives us a total of $41. So that could be one equation. Now the other equation says your friend, so which one is your friend? Well, we let our friend be Y, so we're going to say Y equals, and then it says painted faster and earned $4 less than, so that means I'm taking 4 away or subtracting it from twice what you earned. Well, you are X, so twice what you earned is 2X. 4 less than that means we're taking 4 from it. So we could write that second equation, Y equals 2X minus 4. Now we have two equations, and believe it or not, we can combine these in a way that will make it so that we can find out exactly what we each earned. So we just completed our first step. We defined our X and our Y variables. That's always the first thing we do. Establish your variables. Next, we want to convert both equations into Y equals mx plus b form. If you recall, the reason we want to do that is because m stands for our slope and b stands for our y-intercept. So that'll make them real easy to graph. And then finally, our third step is the solution is where the two graphs intersect. All right, now that we have our 3 steps into finding our solution, now we just have to put them into practice. So we've already done step 1 on this question. We defined the variables. So that was done right here. So now we're on step 2. We want to convert both of them into Y equals mx plus b form. So that first equation is not in Y equals mx plus b form. So all I need to do with my x plus y equals 41 is solve it for y. So I would just subtract x to both sides, and we would get y equals negative x plus 41. Remember, I want my x term written first because it's in slope-intercept form. So now we have our second step complete. So we can check off that second step and the first step. And third step is we need to graph them to see where they intersect. So I'm going to take y equals 2x minus 4 and y equals negative x plus 41, and I'm going to graph them on my graph paper. And I need you to do that with me. All right, on your graph paper, we're just going to go ahead and make each one of these hash marks. Let's see. I'm looking at it. My y-intercept here is 41. So it's going to go up pretty big, huh? So maybe if I go by 5s here, so 5, 10, 15, 20, I'm going to label every other one. So each of them are going by 5, so I can label every other one going by 10s. So that's 30, 40, and then maybe up to 50 there. All right, and then for my x-axis, maybe we can go by 2s. So 2, 4, and I'm labeling every one, 6, 8, 10, and you can see they're going by 2, so that one would be 14, 16, 18. You don't have to label every one. 20, 22, maybe I'll go up to 26. And up to 30. Let's stop there. All right, so our first graph. What's our y-intercept on the first graph? It's -4. So that means if I go down 4, so that would be down below. These go by 5, so that's almost 5 below, which would be right there. And then my slope is up 2, right 1. And this one may not be an easy one to see, so we'll just draw a general sketch of it here. If I went up 2, right 1, it would be about there. Up 2, right 1 would be about there. And again, this isn't real easy to see on this graph. It's going to be way more accurate if we're going by ones. We're going to be able to see that a lot easier. Okay, because I'm looking at my slope. My slope is 2 over 1. So I just need to go up 2, right 1, up 2, right 1. And that'll just show you a generic sketch. And since this is just our first one, you're just getting the idea of it. And actually the graph would look something like that. So just keep in mind, we're taking our y-intercept and our slope and we're rising and running to get to our next points. Okay, take a look at the second equation. Our y-intercept's 41, so we're going to start up at 41, so right about there. And then our slope is -x. That's really a -1 over 1 for our slope. So that means we go down 1, right 1, down 1, right 1, down 1, right 1. And we're going to keep doing that, and this is what it's going to look like. And you can see right where those two intersect is going to be right here, which is going to be 15, 26. So again, if you're graphing this accurately and going by the slope carefully, you're going to see that that's 15, 26. All right, so what does that mean? Well, x is 15 and 26 is y. So this has to mean something. Let's look back at what we said earlier. Oh, x is what you earned, so 15 bucks. And y is what your friend earned, 26 bucks. And just check it. Does that make sense? Yeah. If you doubled 15, you'd get 30, and take away 4, you'd get 26. So yeah, that makes perfect sense. And both of those numbers add to 41, so it checks. So that leads me to the next important thing. You can always check solutions by plugging them into both equations. And the key is it must work for both equations. So it must work for both equations or it's not a solution. All right, let's look back at our example. I did that one in my head, but I want to show you what I just did. So for example 1, we had x plus y equals 41 and y equals 2x minus 4, and we were checking our solution of 15, 26. Well, 15, 26 represents our ordered pair, so the x is our 15, the 26 is our y. So essentially all we need to do here is plug in both of those numbers, so x is 15 plus y, which is 26, and that should give us 41. Add those up, 26 plus 15 is 41, so that's going to check. But don't stop there. That's a common mistake, just to stop there and say, oh, it works. Let's plug it into the other one as well. So our y value is 26, so I'm just plugging that in right in for y. 2 parentheses our x, which is 15, and then minus 4. And I'm just going to do order of operations. So 2 times 15 is 30, and 30 minus 4 gives us, that's right, 26. So 26 equals 26, so that one's going to check. So it must work for both equations, and it did. So we are right on. We know we're correct. All right, we're going to try another example that's going to work a little bit better on our graph, maybe some smaller numbers here. Let's begin. All right, our question is, for example 2, solve 2x equals y minus 6 and x minus y equals 8. All right, so our first thing, if you recall, is define our variables. Well, we already have our variables. We have our x and our y, so we're good there. Second, we want to convert both of them into slope-intercept form. Well, that's not done. So I'm going to write down the 2x equals y minus 6. I want to get y by itself. So if I just add 6 to both sides, y is going to be by itself, which is what I want. And I'm going to rewrite that. It will be y equals 2x plus 6. I like my variable to be on the left. And then I'm going to do the same thing with my other equation, x minus y equals 8. It's not solved for y, so I need to get y by itself. And what sign is that x? Yeah, it's a positive, so to get rid of it we do a minus x. And we do that to both sides. So our x's cancel, and we have a, not a positive y, don't forget that negative sign there, that's a negative y. So negative y equals, I'm going to use the commutative property and make that a negative x, and the 8 is positive, so that's plus 8. I'm thinking ahead because I want it in slope-intercept form. And I'm not done because that's really a negative 1 there in front of the y. So if I divide everything by negative 1, my negative 1's will cancel and y will be all by itself, which is what I want. And really that's a negative 1x, and negative 1 divided by negative 1 is positive 1x, or just x. 8 divided by negative 1 is negative 8. So I end up getting y equals x minus 8. So we've done our first step, check, we defined our variables. Second step, we solved each of them for y, got them in slope-intercept form. Now our third step is going to be to graph them and see where they intersect. So using your graph paper now, let's go ahead and graph each of those equations. Alright, starting off, we're going to graph the y-intercept, which is positive 6. So up 1, 2, 3, 4, 5, 6 on our y-axis. And our slope is 2 over 1. So that means we are, for 2 over 1, we're rising 2 and we're running 1. And I can also do the opposite, which is down 2, left 1. And I'm going to do that since I'm at the top of my graph here. So down 2, left 1, put a point. Go down 2, left 1, put a point. Down 2, left 1, put a point. Down 2, left 1, down 2, left 1. And we'll stop there. That should be good. And now we're going to graph our other equation, our y equals x minus 8. And I'm going to start with my y-intercept of negative 8. So if I go down 8 from the y-axis, that would be down here with the blue mark. My slope is really 1, which is 1 over 1, if I were writing that as a ratio. And 1 over 1 goes up and right, since it's rise over run. So if I go up 1, right 1, up 1, right 1. And I'm actually learning quickly. I want to do the opposite, which is down and left. Whoops. So if I go down 1, left 1, down 1, left 1, I want to see where these two graphs are going to eventually meet up. And I hope you have enough space on your graph there, because if I keep going down 1, left 1, it looks like it might take a little while for that to happen. So I'm going to keep going with my other graph. So down 2, left 1, down 2, left 1. And you can see wherever these meet up is going to be where our solution is. And it looks like I just found it. Down 1, left 1, down 1, left 1. Almost, huh? Looks like it's going to be right there. Now, I guess I didn't make the easiest of examples, but you should get negative 14, negative 22 is the ordered pair where they cross. So negative 14, negative 22, and again, that was going to be right over there. So sorry that one wasn't the easiest example, but you can see the idea there, and hopefully you got to practice your slope a little bit. Yeah, I know, it'd be more fun if you were skiing on it, huh? Alright, let's hit up one more question before we leave today. And this one's going to be another application. So example 3. Alright, copy down example 3. The perimeter of a rectangle is 14 centimeters. The length is 2 less than twice the width. Find the area. Alright, first step. We want to establish or define our variables. So I could let x be the width, and I'm going to do that because I see everything is in relation to the width, so x is going to be the width, and if I make x the width, then I'm going to make y my length. Alright, second step. My perimeter formula is 2 times the width plus 2 times the length gives me my perimeter of 14. So that's just the perimeter formula for a rectangle, because your width and your length are going to be the same on both sides of that rectangle, right? So if that was your width and that was your length, the lengths are going to be the same and the widths are going to be the same. Alright? Alright, next up it says the length, so my length I let be y, so y is means equals, I'm just translating this into an equation, 2 less than means I'm subtracting 2, and twice the width, my width is x. So putting that all together, it's y equals 2 less than, I'm taking 2 away from, twice the width, or 2x. So there's my second equation. And they need to both be solved for y. So that first one I'm going to do a little something to. So 2x plus 2y equals 14. I need to get y by itself. So if I subtract the 2x to both sides, I get 2y equals negative 2x plus 14, because that's a positive 14. And then I want to solve for y, so I need to divide 2 to everything. And it would be y equals negative 2 over 2 is negative 1x plus 7. So now both of my equations are solved for y. Sweet. Now on to our last step, we just want to graph each of these and see where they intersect. So using your graph paper, we're going to go ahead and graph these two. Alright, the negative 1x plus 7, my y-intercept 7, so up 1, 2, 3, 4, 5, 6, 7, I put a point. And my slope's negative 1 over 1. Negative 1 over 1 goes down 1, right 1. So down 1, right 1, down 1, right 1, and I can keep making points. I'm going to do that all the way to the x-axis, so right there. Alright, next graph, I'm going to do that one in red. So my y-intercept's negative 2, so I start off at down 2 from the origin. My slope is 2 over 1. 2 over 1 as rise over run would be up 2, right 1. So up 2, right 1, up 2, right 1, up 2. Oh, right there is where they cross. Up 2, right 1. So once you see where they cross, which would be that point right there, that's your solution. So that point is 1, 2, right 3, and up 4 is my solution. And my 3 is my x, and my 4 is my y. So what does that mean in context of this problem? Well, we let x be the width. So my width is 3, and y is our length, so our length is 4. And it says find the area. So if my width is 3, my length is 4, my area is just going to be length times width. So the area is going to be 3 times 4, which is 12. So your final answer for example 3 is 12 centimeters squared. Alright, that wraps it up. So wherever the two skiers collide is our point of intersection or our solution. So, bam!